In previous video, we explored the different options that we have in Azure for the load balancing purpose. And today we are going to talk about Azure Load Balancer in detail. We understand the theory first, then next video we'll do the demo. Okay, and Azure Load Balancer are of two kinds, basic and standard. So let's talk about the basic first. Hello everyone, my name is Arun and let's get started. So in order to understand the Azure Load Balancer, let's try to create a diagram that would help us to understand from where the traffic is coming and how it is going to the backend VM, and then how it goes to the the database or maybe the business tier. All right, so we need to understand this. Azure Load Balancer operates at layer 4 OSI model. Okay, so let me write this down here. The traffic is coming on port 80. We talked about ports in the previous video on a load balancer. And we have, let's suppose, few machines running at the back end. This is VM. Okay, and this traffic comes to the load balancer on port 80, and then it passes to these VMs at the back end like this. Okay, to these VMs on the port 80. Let's suppose this is our front end, or maybe the web tier, you can say like this, front end or web tier, which is supposed to be accessible from the internet. Okay, let's suppose this is an application, so this load balancer has the public IP address so that people can access it, and that's how the traffic goes to these VMs. Okay, now this front end has the web tier, so you're gonna need the business tier or the database. So let's suppose we have one more tier, that is backend. Okay, so let me move all these VMs at the backend as well, and we need load balancer to cater those requests at the backend as well. Okay, so it would be more like the traffic is coming from these VM to this load balancer, which is not supposed to be accessed by the internet, because we don't want anybody to access our business logic or the database. Okay, and this load balancer sending traffic to backend VM just like this one. We'll explain each and everything, just need to draw this structure to understand what is happening. Okay, now this is our backend, could be business logic, could be database. Okay, backend tier. Hope this is clear now. Now, load balancer distributes inbound flows that arrive at the load balancer's front end, okay, to the backend pool. So this is the backend pool. Yeah. Okay, this part is the backend pool. Okay, for this load balancer, which is accessible, which has the public IP address so that the web application can work and people can access the application. And this is the backend pool. Same goes in this scenario. This is the backend pool for this load balancer which has private IP address. Okay, so whatever traffic comes here on the front end of the load balancer, it distributes evenly to the backend pool. Okay, clear? Now we need to understand this. This load balancer has, or this is public or external or PIP is there on this load balancer. Okay, but if I talk about the backend load balancer, this is not like this one. We can call it internal, okay, or private LB. Cool. All right, so when we'll do the demo part in the lab, you would be able to make sense of everything what I'm saying right now. But just try to be with me, try to understand. You access, let's suppose, facebook.com or google.com. That request goes on the load balancer, and these machines at the backend pool serves that request, and whatever changes or the thing that you have request would fall to this load balancer from the front end, and as per the database it goes here. So that is the complete structure of an application. We need a front end, we need a back end. These VMs will cater those requests coming from the front end, and these VM would cater those requests which is coming from internal load balancer. So basic load balancer is of two kind, external and internal. Okay, now external can provide outbound connections to the virtual machines inside your virtual network. These connections are accomplished by translating their private IP address to public IP address of the load balancer. Okay, by default, every machine in Azure can access the internet, doesn't matter what kind of IP it has, private or public, but here it will translate this public IP rather than Azure's. Okay, and internal is used where private IPs are needed at the front end only. Internal load balancers are used to load balance traffic inside a virtual network. Okay, a load balancer front end can be accessed from on-premises network in a hybrid scenario. Cool. All right, now let's go and talk about the different components of a load balancer. Okay, and in the same diagram we'll try to make sense of those components as well. All right, so the very first component is this IP. We talked about public IP and private IP configuration that decide what kind of load balancer you have. Then we have the backend pool. So if you are using a basic load balancer, your backend pool could be, let me write this down here. Your backend pool could be a VM or VMSS. That VM could be a part of availability set. Okay. All right. Now, let's suppose there are 4 VMs and this load balancer is distributing traffic evenly to these 4 VMs. But how come this load balancer knows that these VMs are up and running? There must be something which will tell this load balancer that this VM is up and running and can cater the request. That thing is called health probe. Okay, that thing is called health probe. So health probe is just like the heartbeat of the VM. You can define this on TCP or HTTP port. Okay, and this will health probe will keep telling the load balancer that you can send request to this VM. If your load balancer missing the health probe, that means load balancer will think that VM is not up and running and will not send traffic to that VM. Okay. So a health probe is used to determine the health of the instance in the backend pool. You can define unhealthy threshold for your health probes when a probe fails to respond. The load balancer stops sending new connection to the unhealthy instances. A probe failure doesn't affect existing connections. Okay. If the connection continues until the application idle timeout occurs or VM shuts down. And there are two kind of health probes. I did mention it, but let me write it down. TCP and HTTP for a basic load balancer. Okay. But if we talk about standard, we do have HTTPS available. Okay. Now, load balancer distributing the load to these backend VMs. So how this is happening? Those rules are called load balancing rules. Okay. Load balancing rules are the rules that tell the load balancer what needs to be done and when. Okay. When we create the load balancer and the load balancing rule, you would understand more if you are a little confused right now. Now, there is one more component which is called inbound net rules. An inbound net rule forward traffic from a specific port of a specific front-end IP address to a specific port of a specific backend instance inside the virtual network. Port forwarding. Yeah, port forwarding is done with the help of net rules. It is more like you have a load balancer, like public load balancer, in the back end you have a VM running. So, and you don't want anybody else to take the RDP of that VM because you know uh, that has a public IP attached to the load balancer, but you can do the port forwarding. You can use that public IP with a certain port to access, to lend or to transfer traffic to the port 3389 of that VM. Okay. All right, we'll do it. We'll do the port forwarding that you can understand. We are trying to access the RDP over port 443 and we gets the prompt because in the back end, load balancer is transferring the traffic to a different port. Okay, cool. So these are the components of a basic load balancer. This is how it works. In next video, we'll do the demo. There is one more thing I just wanted to go through here, which is known as 5-tuple hash. Okay, so if we talk about the logarithm on which this Azure load balancer is working, that is 5-tuple hash. Okay, let me try. No, we don't need this. Let me try explain this a little bit. All right, we can say this is load balancing a log rhythm. Also say 5-tuple hash. Okay, so with Azure Load Balancer, you can create a load balancing rule to distribute traffic that arrives at the front end to the backend pool instance. Okay, which arrives at the front end to the backend pool instances. And load balancer uses hashing logarithm for distribution of inbound flows. Okay, and rewrites the headers of flows to backend pool instances. It is more like round robin, but the logarithm which runs is the hashing. Okay, a server is available to receive new flows when a health probe indicates a healthy backend endpoint, and by default, load balancer uses 5 tuple hash. This health probe says like happy in running this VM, and this uses 5 tuple hash and sends the traffic. What is 5 tuple hash? You must be wondering. Okay, well, let me write it down. What 5 tuple I'm talking about? Uh, Come on, right here. So, what is 5 tuple? There are 5 things which decides the random distribution of the traffic, which is source IP address from where the traffic is being requested, source port on which port the application is being accessed, destination IP address. This is for the load balancer, on which backend VM the load balancer is sending the traffic. That would be the destination, okay? And on which port it is sending the traffic. And the fifth, last but not the least, is IP protocol number to map flows to available servers, okay? IP protocol. So that's how it determines where to send the traffic. It looks round robin, it is round robin, but that's how it is happening. IP protocol number uh, to map flows to available servers. Okay, and because of this 5 tuple hash, you can also create something called session affinity. Okay, this is 5 tuple hash. Okay, now you must be wondering what is session affinity. It is more like, let me get back to this diagram. This load balancer sends information to the request to these 4 VMs. If you enable the session affinity, load balancer has the information of the source IP and source port and the destination and IP destination port, and it will keep sending to that particular VM. That session has been, uh, jammed for this VM. That would be session affinity. And you can create session affinity to a source IP address by using 2 or 3 tuple hash for a given rule. All packets of the same packet flow arrive on the same instance behind the load balancer. Okay. And when the client starts a new flow from the same source IP address, the source port is changed. As a result, 5 tuple hash might cause the traffic to go to a different backend. So that's how load balancer knows from where the traffic is coming, from where the traffic will go, and that's how you can ask load balancer to send the traffic to a particular VM by utilizing 2 or 3 tuple out of these. Okay, so that's all the whole and soul of this basic load balancer. There are a few more points that we'll talk about during the demo part, and thank you for watching. You have a good day.